that we need a lot more computation and a lot more connectivity. And once we have that, we can deliver what we call apps for your ears.
Shure, the company making people sound extraordinary for nearly a century. Shure provided the MV7 podcast microphone and SRH440A professional studio headphones used in this episode. Each are available now at shure.com, spelled SHURE.com.
Welcome, everybody. We have a very special guest today. His name is Gary Spittle, and he's here to talk about the future of audio with his brand new company that he's the founder and CEO of called Sonical. Welcome, Gary, and let's dive into the future of audio.
Fantastic. It's a pleasure to be here. Thanks for inviting me to talk about what we're doing. Sonical, I guess I'll start with a little bit of history about how we got here. So my background actually is I started working in the pro audio space many, many years ago, and we were building very high-end equipment for recording studios, TV studios, and Hollywood. And through that process, we learned about the importance of audio quality and what people want to do with audio for entertainment. Since then, I've worked for various consumer electronics companies. We were part of the founding team that really got Bluetooth audio going back at CSR in England. Okay. And since then, of course, Bluetooth headphones are everywhere. Right. So we see all this innovation happening. And in particular, myself and my team, we spent the last sort of 5 years doing consulting projects for all the big headphone companies and technology companies where we got this privileged insight into what technology is coming down the pipe. And that's where we saw this enormous gap in terms of what headphones really need.
Okay. So you have a specific technology for headphones, which I think you're calling it I'm going to bring it up on the screen here, Headphone 3.0. What's the difference between Headphone 1.0 and 2.0?
Okay. Yes. Good question. How did we even get to 3? So headphones really started off and became sort of publicly acceptable when we were listening to music with the Sony Walkman, and people were wearing the little tiny headphones on, listening to music outside, and when we were sort of walking down the street. And since then, we've just evolved into what we have today. So from Headphone 1, where the devices just kind of squirt sound in your ears and we play music, we then had Headphone 2, which was really driven by Bluetooth. So Bluetooth enabled us not just to go wireless, but it added a processor. So now we can do interesting things with the sound. We can make the headphone have a different frequency response. We can change profiles. We can remove noise. We can now use the device with microphones to have phone calls. So suddenly, this device has become very interesting, and it's attracting a lot of new innovation. So Headphone 3 takes it to the next level. And what we've done is we've looked at, what do people really want to do with these devices? And what we found is that we need a lot more computation and a lot more connectivity. And once we have that, we can deliver what we call apps for your ears. So in exactly the same way that we use apps on our phone to personalize them, we will use app for our ears to personalize how we listen to music, how we listen to the world, and most importantly, how we listen to our bodies, which is really the secret sauce.
Okay. So it sounds like wired was Headphone 1, wireless with Bluetooth, Headphone 2, and Headphone 3 is this concept of apps for your ear. What are some of these apps that you have in mind, and why aren't we there yet? Like Apple's making apps, and other companies have various apps on your phone that you can use with headphones. Is that what you're talking about, or something different?
No, I think that has been the initial first steps. So, companies like Apple with the AirPods have provided these new applications and features that would normally be quite difficult to do with a standard Bluetooth chip.
Okay.
So it's given us a taste of what's possible. And what we found through our consulting work is there's an enormous ecosystem of people developing new experiences, but they're just not getting into the product. So it's not just about, improvements for listening to music, but how could we get surround sound and immersive audio when I'm watching a movie? How could I have intelligibility improvements by separating talkers on a conference call? So, just how we interact with sound has many improvements. The other area that we see a lot of people working at the minute is how we hear the world. So, how we can benefit the end user with intelligent noise control. So rather than the ANC that we have today, which really just cancels all sound, it's a lot more intelligent, so it can selectively remove sounds and maybe give you some control about how much of each sound is actually removed. And then the final piece, which is by far the biggest area that we see innovation happening, is around listening to your body. So the ear is a great location for listening to, your heart rate. You can gather your temperature, motion. There's companies developing all kinds of sensors that could be resident inside the ear. And what that allows us to do is, for example, when I'm listening to a piece of music, I can measure the impact of that music on me as a person. So I may be listening to music that I want to help me relax. Well, now I can detect whether it's actually been effective, or it may be something that I'm using to go to sleep. So now we've got this interaction. Not only can we improve the experience, we can actually measure whether it was effective or not.
Okay, I think it sounds like you're saying there are sensors in your ears, because that's something I don't believe exists on any headphones right now. There's some kind of sensor within the earphone that's able to measure heart rates, temperature, things like that.
Yeah, there's not very many of them at the moment. And again, this comes back to the reason for that is it requires new types of interfaces or more interfaces on the chips. And a lot of today's sort of single chip systems were never developed with this in mind. They were simply there to play music over Bluetooth. And so if you think about the ear differently and actually start with the ear rather than Bluetooth, you end up in a much different place. So we would have sensors, we would have not just one radio, but perhaps multiple radios to do different things. We'd have much higher bandwidth. We would be running multiple applications at the same time that the user can change at any moment. So we really are thinking about it as if it was an ear computer.
Right. Ear computer. That's an interesting concept. Don't think you've heard those words together very often. Yeah, when people think of ear computer, they think of like putting a laptop next to their head. But is that partially what you're miniaturizing? Like everything?
Yeah, it's not far from it, actually. So if you think about the laptop, shrunk down to a smartphone, and the phone is now able to run multiple apps with amazing amounts of compute. That has now shrunk down to the smartwatch. We're shrinking it to the next level and sticking it in your ear. And so we can gather a lot more data. We can actually interact with you in a much better way. And we use these other devices as a graphical interface. We would still use the watch to control what's going on in my ear, but all of the information is done locally.
Okay. It sounds like you have intellectual property. You've developed some methods of doing this. Is this close to being an actual product, or is this, I guess I'm trying to understand what your company is angling to do. Like, are you trying to license the technology, or are you building a product that the end user might buy?
Right. So, no, we don't intend to make the end devices. We work with the headphone companies that can build all the acoustics and the mechanicals, and those are the experts in that space. And that's why we were, at CanJam. We deliver the technology engine that goes inside it. And that's a combination of the operating system that we call Cosmos and the processor that sits underneath it. And we have a whole range of different chips at different capabilities that manufacturers can then use. So if they want a sort of basic device, they can use chip A. And if they want a really premium device, they can use chip B. But the Cosmos operating system gives them a consistent way of bringing apps to their customers.
Okay. Does your company produce the chip, sorry, or just the software that goes into the chip, and then there's another company that does the chip?
So right now we're just developing the software. The chip design is in progress,
Mm,
and the software runs on multiple third-party chips that are already available in the market.
okay, and where are we in the technology um, ad- advancement? Like, do you need to um does there need to be new technology that has to come out first before your innovations can go into effect, or can they work now with existing earphone modifications? Like, it does that make sense?
Yeah. So right now we have a whole bunch of apps that are available. So these are algorithms that enable you to have spatial sound. We can improve how you hear the world with noise reduction. We can enhance your speech if you're on a voice call. So all of these kinds of algorithms are available, and it's a growing ecosystem. And they will run on today's chips with no problem at all.
Okay.
But what we've seen is what those companies are developing next, which is based around neural networks and very
Mm,
intense AI-based algorithms. And a lot of today's chips, they simply can't cope, or they can only run one of these algorithms at a time. And that's not
right.
very helpful for the user. We want to run multiple apps. So we see this shift towards a much higher level of computation.
Okay. Yeah. That's where you corrected me. So I was getting at, are the processing speed of the chips able to keep up with the technology that you have, or do we need a few more years of innovation of silicon, how they can shrink the chips down? That's kind of the question.
Yeah, so right now the real issue is time and money. So
Mm,
to build these really efficient small chips is absolutely possible. You need to define them in the right way, but it costs a lot of money to build silicon at those process geometries.
right.
And the challenge is with that is you have to match it to the user's expectation of a headphone. Are they willing to pay a premium to get access to these apps? And so far, with our very early adopter customers, we're seeing that they absolutely do. They really want to get access to these new experiences, and they're happy to pay a premium for that.
Okay. So it sounds like you're saying there's some way to experience this now through a smartphone app. Some of your um, to demo what you're capable of. Is that kind of the prototype phase that you're in now?
Yeah, so our prototype, it's a basic ear computer. So it's a
Mm,
chip that runs our software. And it obviously has limited capabilities because that's what we have access to right now. And using a smartphone, we can download apps to the phone. And then within those apps are what we call plugins. And we take a selection of those plugins depending on what the user wants. And we
right.
send them over the wireless link so that they are actually running inside the headphone. So I can go and pick whichever combination of apps I need. Do I need noise
Right.
reduction? Do I want voice enhancement? Do I want to hear in a noisy coffee shop? I create my own profile. And then when I change my use case or I want to go and do something else, I just use my phone to select a different set of apps and I download those to my headphone.
Okay. And now it's starting to sound like there's an app store for your ear. Is that part of the vision, that there's a lot of things you can do to your ear um, through some kind of app store like Apple offers, or sounds like you're going to have your own app store of Cosmo OS, of how you might access some of these features? Is that part of the menu?
Um, it could be. So we don't want to necessarily reinvent the App Store. There's
Mm,
great places where we can go and get apps right now. And
right.
so we're looking to utilize what is already there. And our developers are putting their apps up on iTunes and Google Play so
Right.
that the end user can go and bring those down to their devices. So that's already in place.
Okay.
Where we do see things changing is sometimes the product companies would like to have their own sort of walled garden of apps so that they
Mm,
validated, and they want to make sure that the users always get this premium experience, which makes a lot of sense. And so they would go and hand select a range of apps that then their users can go and get access to when they need them.
I see. So it sounds like you can sell proprietary kind of white labeled services to different headphone companies that want to access some of your technology as one option. Um, is that part of the product menu? I guess I'll go back to.
Yeah.
Yeah.
Yeah. So we have that ability right now. So we have what we call a dashboard that other companies can go and populate with all the plugins that they want.
Okay.
And we actually provide that to them, and they could then brand it in whatever logos and graphics that they
Right.
want. But all of that mechanism is in place. So right now we are able to demonstrate downloading apps to your ears. And in the future, of course, that ecosystem we want to grow as much as possible and really open up that innovation.
All right. Now I kind of want to step back a little bit. Take me back to the beginning of this company. Like it was, the beginning idea that you had or a group of people had that said, I think there's a business here and we have the innovation to do it. Can you take us back to
Yeah.
that? And when was it?
So as I mentioned, we were doing a lot of consulting work, and one of our particular projects that we worked on, the project manager was defining what they wanted to put into their next headphone. And this was a project that they expected to last, maybe a year to get this new feature in, and we were helping them along the way.
Okay.
It ended up taking much longer than anticipated. As most technology
Always
projects
does.
do. Yep.
Right.
And so when we eventually got there, there was still a big unknown. Would their customers like it? Were they going to use this new feature? Now that they've done all this work, it's really hard to kind of predict this. Even with some of the big market studies they did, it's hard to know for sure whether the customer likes it. And fortunately, they were able to do some early alpha tests, and people were enjoying the experience, and so they went ahead. But afterwards, the project manager said to us, it'd be really good if we didn't have all this pressure, where we could just build this great headphone and then let the user decide what features to put inside it. And if they don't like it, it's okay. They don't then blame the product. They just choose a different app. And so we thought about how we could do that. And, we're all using mobile phones. So it's like a phone with an operating system, and I can just download the apps as a user. And they said, yeah, that's what we really want.
Right.
And so we built one, and we prototyped it, and we showed them what's possible. And they said, yeah, that's what we need, because now these project definitions, they don't have to be so involved. They could be 20 different apps that they have to select from. And the guy, in the product company, he has no idea which ones their users are going to need. And so they pass that over to the user. You go and pick, here's 20 apps, you pick what you want. So that's where it started. And then we realized, of course, that
how long ago was that?
So that was, is coming up to about 3 years ago.
Okay.
And so, based on those consulting projects, we built the software ecosystem. And we were already talking to a whole bunch of algorithm developers, and we got those guys involved. But then we very quickly realized that today's chips could never support the different configurations that a typical user wants. How are they going to run all of these apps simultaneously? So we quickly ran out of memory. We ran out of computation. The power consumption was no good. And so we went on a hunt to go and find some other potential processors, and now we've got some, but we also know that that's not going to be enough to see us into the future. It's a bit like the processors used in phones and laptops. They're on this trajectory now, and they just keep getting faster and better. And unfortunately for the ear, we've barely gone anywhere in the last 20 years because we've been fixed on this Bluetooth use case. Now, when you detach from that, you realize there's so much more that could be done.
Okay, so now it sounds like you're talking about not using Bluetooth. So are you talking about Wi-Fi, 5G? What are we talking about to get sounds in your ear?
So Bluetooth is obviously a worldwide standard, and it's great for interoperability, even with its limitations. So we obviously support Bluetooth as one of the data pipes into the system. But most of our early adopter customers are looking at additional radios or alternative radios that give them the higher bandwidth, much lower latency, and also more efficient in terms of audio streaming. So we have companies looking at UWB-based systems or Wi-Fi-based systems. And yes, we do actually have one customer that's looking at a 5G kind of configuration, not necessarily putting 5G on the headphone itself, but on a connected pod that would come along with the device when I buy it. So now I can go outside and have a direct connection to Tidal or Qbuzz and get high quality audio straight to my headphone. I don't have to go through my phone anymore.
Okay, so I think in that scenario, you're talking about having like a cell phone receiver inside the earphone itself.
Yeah, that's right.
Okay, and that currently doesn't exist as far as I know of any headphone right now.
No.
But is that something that you need to happen for your company to be successful, or is that just one of the parts to how your service can accommodate so many features?
No, it's not critical at all. As long as we have some access to a data pipe, it could be USB, it could be Bluetooth. We just need to get data in and out. And it's just one of those capabilities. It's a bit like, when you buy a tablet, do you buy the one with the cellular connection, or are you okay with just Wi-Fi? It's your choice. And we're seeing the same thing happen. People are building headphones with Wi-Fi so they can connect into devices in the home. They're using UWB so that they can get low latency for gaming. So they're looking at these alternatives, which means you have to step outside Bluetooth and then look at how do I connect all these things together.
Right. UWB is ultra wideband for people that weren't catching that. It's a technology that hasn't really caught on. I believe it's built into a lot of phones, but I don't see right now a lot of products that are utilizing, I guess, ultra wide bandwidth. I mean, that's what it stands for, to get faster connection. Do you know what's holding that up by any chance?
It's mostly because Bluetooth has such a strong hold on all the devices that we use. But ultimately, we're finding that users aren't necessarily attached to the type of connectivity. They just want their devices to work. And if their headphones switched to a different radio protocol to get the lower latency and the better efficiency and a higher bandwidth, they just want that to seamlessly happen. They don't want to have to go into their phone and select all these different settings.
Right.
So that's what we see the transition doing.
Just to give people some context on different speeds, how would you characterize the speed between Bluetooth, ultra wideband, 5G? Do you have like general?
Oh, so I guess very roughly, I mean, what we have today with Bluetooth, UWB is going to be about 10x that.
Okay.
And then I guess with 5G, it's going to be about a 10x again. Okay. And so right now, there's maybe a limit on the use cases. But as soon as you offer people an alternative connection, they already fill it up. They're already saying, oh, now I can stream, MQA over the air, or maybe I can stream 5.1 surround sound over the air. So all these things that we didn't think we needed, all of a sudden people are building products that are using it.
I see. So I think you're saying 100 times the bandwidth connection to your ear. So whether it's sound, whether it's sensors to go back, whether it's vital data, there's all of a sudden this new way to capture information at a 100x speed. So it's instantaneous, and spatial audio, it sounds like, is fitting in there, and all kinds of extra digital signal processing so you can enhance or create the sound and do noise canceling and all the stuff that we know of. Did I accurately try to summarize that? Or
that's
I guess
right.
The better question is, what did I leave out, and what's the potential possibilities when you get to 100x connectivity to your ear?
So the way we see it is the two things work in conjunction with each other. So you have the processing and the connectivity. The two have to be tightly coupled. And so if you offer people the ability to process more data, they need to know where is it coming from and where can I send it. So, if I was to have a lot of sensors in my ear and it's continuously monitoring what my body's doing, I may want to be able to offload that data at certain points during the day. And I don't want it to take a long time, and I want it to be super efficient. Also getting data in, all these different apps and programs, all of that data's got to get into the earbud, and it needs to be, again, very fast. I don't want to wait 20 seconds for it to load up a new application. It needs to be immediate. So by opening up the capabilities, we're letting other people innovate. And so now they're not held back by the limitations of Bluetooth. They can do some really interesting things. We've got people adding all kinds of accessories onto their earbuds and all kinds of data streams, multiple connections to other devices, very high bandwidth audio. Some of them are even capturing images of certain things. So now the sort of the gloves are off, and now people are creating all of these new features, and we simply just enable them. We just get out the way and say, sure, go ahead and build that.
Right. So it sounds like you started 3 years ago. How have you advanced the company in 3 years, and kind of what stage would you classify it being at now?
So right now we are working with some early adopter headphone companies that will be launching products pretty soon, and they'll be using our Cosmos software to bring these apps into their new products. That'll be using a whole bunch of new silicon that other companies have built, and then we'll be growing that set of chips that are available over the next 12 months. And up to this point, we've done obviously a lot of learning. We've been figuring out what people really want to do, and we've been prioritizing enabling these features to get into a device that are beyond what's possible with a standard Bluetooth headphone. So rather than basic TWS audio streaming, what could we do that's different? Is it going to be TWS Pro because now the UWB is used? Is it going to be an over-the-ear headphone that lets me have surround sound when I'm watching a movie? All of these things are things that we are looking at.
All right. Just quickly, TWS is True Wireless, abbreviation for True Wireless, which just means like AirPods, earbuds, without any wires between them. So just to, but I think everyone's familiar with AirPods, but they may not understand TWS. So I just wanted to quickly clarify that. So in terms of funding and cost, does your company need funding now? Do you have enough customers to support you? How are you doing in that phase?
Yeah, so we're about to start a new round of funding for the silicon development. So that's in progress. We are working with some very interesting strategic partners to build out that ecosystem. In terms of customers, I guess we've been inundated with requests to go and put new technology in the ear. People have been held back for so long now that we've suddenly opened up this new opportunity. And what's been really interesting is everyone's heading in different directions. It's not like we just build one system that's going to be great for everybody. We've got people building all kinds of new products and really looking at some of these blue ocean areas that have never been touched before. They've been completely off limits. So customers, we're doing our best to keep up. We're growing the team in terms of software development. We're opening up a new office over in the UK specifically for ear computing. So it'll be a center of excellence that will be looking at what we could do with the ear if those resources are available. So there's a lot of great things happening. And really, this is just the start. And I think over the next few years, we'll start to see more ear computers and some hopefully really interesting features.
So is Sonical a brand people should look out for, or are you kind of going to be behind the scenes, and other companies will kind of rebrand what you're offering?
So we're more of a B2B. So we're working with all of the headphone brands. It would be great, obviously, if we were recognized, in the same way that people remember Intel Inside and things like that. But that's not necessarily our intention. We just want to be recognized for making people have a great experience and the developers' lives a lot easier.
All right. Well, let's say everything works out and your company's successful. What would the future look like for both your company and for the end user?
Oh, goodness. So I think for the end user, it's just giving people access to technology that hasn't been possible. One example is in the new OTC hearing aid
Hmm.
products. That's a huge opportunity to really bring advanced signal processing to people that really need it. There's
Right.
a lot of medical applications that we're looking at too. So for our focus is, enabling those types of scenarios. I guess success with Sonical is making that happen. How do we help people deliver these features in a really
Right.
fast way? And how do we learn from that and make sure that, Cosmos effectively becomes what Android did for the mobile phone? The real story here is the ear is this untapped resource, and we're simply giving people access to it.
Well, yeah, I think that's maybe a great way to end it then. The ear is an untapped resource. I think that's very well said. Um, you've been watching ecoustics.com. This is your host, Brian Mitchell, and we've been speaking with Gary Spittle, the founder and CEO of Sonical. Thanks for joining us today.